Okay, next up is Michelle Danyluk from the University of Florida. So she's flown all the way from Florida. And Michelle is going to talk to us on extreme weather events and fresh fruit and vegetable safety. Thank you, Michelle.
Perfect, thank you. Thank you all. So I just checked on my phone. It's 26 degrees at my house at 11 p.m. Currently in Florida. So yeah, 25 is not a warm day. I'm going to talk a little bit of fresh fruit and vegetable safety. I will begin in saying Happy Canada Day. I'm Canadian, and today is our national independence holiday. So happy Canada Day to you all. I am also here on behalf of the International Association for Food Protection, of which I have a really fast slide here, past president. So I would encourage you all to join the association, if for no other reason than our journal went open access, and it's only $1,600 to publish open access, which is less than half than most other open access food safety journals. And with that, I'm going to talk about unexpected weather, or extreme weather, which is maybe not always unexpected. So what this graph has is 100 years worth of tropical storms and hurricanes in the state of Florida. And so I think it would be, one of the questions we ask in food safety and risk management is this something reasonably likely to occur? And I think we'd have a hard time arguing in Florida that a tropical storm or a hurricane is not reasonably likely to occur, right? For us, this is a normal part of the year. June to November is hurricane season. And we know that the majority of those storms start to happen in mid-August, and if we make it through to October, we're probably not going to get a major storm hitting us. If you look at that graph, those red storms are what we would call a relatively important hurricane, and if you meet Floridians, most of them will say that anything below a Category 3 hurricane is not even worth worrying about. It's just a little bit of rain with a name, is what they call it. But once you start getting into Category 3, Category 4, and Category 5 hurricanes, those are when we start to worry, and I've got cheat sheets here because I don't know the kilometer and hour numbers. Category 3 hurricane is somewhere between 178 and 208 kilometers per hour sustained winds. And when we get into Category 5 hurricanes, that's over 250 kilometers per hour sustained winds. So Floridians are crazy because they don't start worrying until you're at like 178 kilometers per hour sustained winds. We know those are going to come in the fall, and we know every year in the spring for us we're going to get a projection. This is a 2024 Atlantic hurricane projection. They forecast for us between 20 and 25 named storms, and then 4 to 7 major hurricanes. I'm pleased to tell you all the first one formed yesterday in the Atlantic Basin. Hurricane Beryl is headed towards the Yucatan Peninsula in Mexico. And we'll get there in the next 3 to 5 days. So I told you all in this room that you had 3 to 5 days to prepare your food company or your laboratory or your office to potentially be without power for the next 5 to 10 days. How many of you would have a plan and be able to do that? Not so many. I heard the answer up front. I can tell you my lab would. We have a plan at 3 days out. We have a plan at 2 days out, and then we have a plan at that last day. And that last day is a very short plan because you have to go home and do all the stuff to your house too. But as these extreme events stop being rare and start being a regular part of your life, these are the sort of plans that you have to start putting in place when you look at risk management. And so as you look forward, and if you think that flooding and these extreme weather events are going to become more normal, this is a kind of more normal planning that you're going to have. I'll tell you, after each major storm, you learn a lesson because you miss something from the previous one and you don't miss the same thing again. So this is not just true for us at universities, this is true for our agricultural producers as well. These are leafy green fields in southeast Florida. They are producing lettuce. It's going into those very scary bagged salads that we heard about in the panel right before lunch. All of those leaves have been consumed in those very scary salads. These are those same fields today. We flood our fields all hurricane season on purpose. We put them underwater before we get 50 centimeters of rain in 24 hours because we know they're going to flood anyway. We don't farm on them, and we flood them for the summer, and they actually turn into beautiful wetlands where you have fantastic opportunity to see a number of different tropical and subtropical bird species. So if you ever happen to be in Florida in the summer, it's ridiculously hot and you shouldn't have come, but you can go and see fantastic wetlands that in the winter are all fields. We drain that land very quickly when we get to the end of the hurricane season into fall, and I'll tell you, if you look at that sort of bottom picture next to the large alligator, that's all what the birds leave behind when they go. So there's a whole different set of hazards introduced by this flooding behavior, but it does sort of prevent the fields from eroding and any crop from being destroyed over the summer. We do this every year. It's sort of what we do. Not the same for our colleagues across the summer. Last summer, they were expecting a hurricane into California, the first one they've ever had, and they reached out to us for our information because they know that we do keep this information available, and we have a number of different fact sheets all around food safety with these hurricane events and flooding. We have ones we put out at the beginning of the year, and then we have in advance of the season, ready to go short snippets that can go out sort of in those 3 to 5 days before a storm comes, where we're prepping, where it's really short sound bites of information that go out to our food and farming communities. But again, most of them, because they've lived through these storms their entire life, do have plans in place and are ready to go. All right, what do we do after the flood? Well, in terms of fresh fruits and vegetables, it's really easy for us. FDA has said that for us, any produce that has touched flood water is considered adulterated, and it's out for consumption. It can't go into human food, it can't go into animal feed, it's essentially done. It's everything after that that becomes hard. Because even when we know these storms are coming, even when we're very well prepared for them, there's tremendous damage. And so we've got damage to worker housing, which is that large picture on top. Picture right below it is a packing house that had a semi-trailer blown into the side, and so you can see the side of the building is taken out. That one was really fun in particular. They'd stored a bunch of boats inside there for the hurricane, so the boats didn't get blown away. One of the boats caught on fire, and then there was a large diesel fire on top of everything else in the facility. We've got wells underwater. We've got greenhouses, high tunnels destroyed, and then in some cases there's an orange tree that's blown completely over because of the storm. So there's a lot of damage that falls from it. Just more pictures. These are fields that were prepped that are underwater that will have to be re-prepped to be planted later on in the year. You often will have cattle that has to be moved very rapidly out of flood areas. So we often see cattle moving across fresh fruit and vegetable fields, which again introduces risks that perhaps you don't think about. Crops underwater. We're lucky, perhaps in Florida, that our agriculture has very much moved inland away from the coast where the houses now are. And so we don't have situations anymore where there's storm surge into agricultural fields. But if you did have storm surge into agricultural fields, then you'd have to worry about that salt water coming into the field and your potential to replant after that. So afterwards is a really hard part. And I'll put that out there. There's a lot of questions from food safety afterwards, but the events aren't just food safety related events, right? And so when we talk to producers afterwards, we need to remember that they're people and their lives are often impacted by this as well. So we have to verify in advance that they're okay, their families are okay, their pets are okay, their homes are okay, that they have access to all the food, water, power that they need, because those things don't happen quickly. And in fact, in a lot of areas that are really significantly impacted, it can be weeks, if not months, until things have really returned to any semblance of normal, long after the event has fallen out of the news cycle. And so when we talk to people who've been impacted by extreme weather about food safety, we need to remember in a context that this is not just a food safety problem for them, it's a problem in their whole lives. And as someone who's been without power at my house for 10 days following a tropical storm, it's really hard to think only about food safety when you're struggling to think how you're gonna get hot food or when your next shower might be. So I'm gonna talk through 3 examples from 2 different hurricanes and then 1 atmospheric surge, and some of the food safety data we found related again to fresh fruits and vegetables and farming. The first is 2011, and it's up in upstate New York where they saw pretty extreme flooding. In this case, they went in and sampled 3 days post that flooding event, 3 weeks 44 days, so about 5 weeks, and then again almost a year, 9 months later. Looked at different drag, soil, and water samples and tested for salmonella and generic E. coli. And what they see is at 21 days, this is prevalence versus day of sampling, 21 days post the flooding event, they still had really elevated amounts of salmonella in the soil, decreased at 44 days, and then when we got out to 9 months, only that water was positive. The question we often have to answer and struggle to answer is that after these flooding events occur, we want to return to baseline, but not a lot of our farmers are measuring what their baseline level of E. coli or fecal coliforms or salmonella is in their soil. So the question is, we're testing to return to baseline, but we don't in fact know what that baseline is. But within 41 days in this case, we were feeling like we were pretty close and the farmers could go ahead and replant. This is Laura Strawn, who's at Virginia Tech University. She happens to be in a unique environment where they have a pond, a water source that's naturally highly contaminated with salmonella. And so she went ahead and intentionally flooded a field with that salmonella-prone pond water to see how long she could pull salmonella out, and to try to answer some of these key flooding questions was, does the flood actually contaminate the soil with salmonella? What's the extent of the contamination? When could we start replanting? And then in the US, in a lot of our guidance documents, we have a 30-foot buffer. And so on my cheat sheet, 30 feet is 9 meters. We have this 9-meter buffer zone outside of the field. And the reason we set that at 9 meters is because that's a turning radius for a lot of our harvest equipment. And so that's the reason that 30-foot was taken. And so she's questioning that in terms of how it would impact food safety. So again, they prepped the field the way they would to plant it, with any crop grown on mulch, plastic mulch rows, and they submerged it in water for 7 days, and then sampled out to 90 days post-flood, looking for salmonella. This is their sampling scheme, so they pulled extensive samples. They pulled 30 samples at each different sampling time point, and then they went out and sampled 30 feet and 90 feet post-sampling. And what she found was, on day 1, they increased from essentially 0 salmonella in the soil as their baseline to looking at between 10 and almost 20% salmonella in those soil, standing water, and drag swab samples they took. But you can see that that decreased significantly, and that really by about 30 days, day 28, we're almost back to our baseline level of very, very little salmonella in the water. And if you look at the way they flooded the field, so the bottom in this case is where they introduced the flood water, moving towards the top, the positive samples for salmonella really sat where that flood water entered the field. So that was the highest risk areas, right where the flood water entered the field. And when they looked in the buffer zone at day 1, they did have salmonella positive samples at 0 feet, a couple at 30 feet. But then looking out beyond 7 days, within that 30 feet, they didn't find any salmonella. So by the time the field would dry out enough to bring equipment back in, that 30-day buffer or that 30-foot buffer or 9-meter buffer is looking pretty reasonable in terms of a buffer zone. So what they found was that didn't find salmonella before the flood, could find it pretty highly after the flood, especially where that flood water entered the field. Pretty highly contaminated, again, spatially, depending on where you found salmonella. And that 60-day recommendation that we see in a lot of our recommendation, you wouldn't see a problem with that. And even as early as 30 days, there could be some replanting. And again, that 30-foot buffer that has been proposed seems pretty reasonable. This last one is looking at a atmospheric river that came through into California after the hurricane that I was asked about. They had an atmospheric river, and they actually had a subsequent flooding event in the spring in their spring in April of 2023 in California. So Monterey Valley of California, just south of San Francisco, essentially 3 major flood events that would be considered century events, 3 within 1 year happening. And in this picture, if you can see the video, you can actually see water running from the Salinas River directly into the leafy green field where they had actually already planted leafy greens. In this case, Chana Rocas at the University of Arizona, this is her data. She looked at 4 different types of flooding from a creek that was next to cattle grazing, flooding from a creek that was a tributary next to cattle grazing, flooding directly from a river, and then flooding from the river directly adjacent to cattle grazing. So looking at the influence of cattle grazing on the flood waters that came through. Again, in this case, this is sort of our benchmark standards for what we deal with flooding, 60 days until the field is dried out, and then you can start sampling early, or you can go in earlier if you can hit benchmarks to show that your soils return to baseline. And in this case, the Leafy Green Marketing Agreement says you have to have less than 100 MPN per gram of fecal coliforms and no salmonella or S-tech on testing. So Shannon pulled a bunch of different samples of water, soil, and again, drag swabs, pretty typical samples. She looked for salmonella and E. coli, and then a number of indicator organisms. She also looked for heavy metal, salinity, and soil moisture rate, because there's more than just microbial hazards in these floodwater. I am not going to discuss any of that data today, but if you're interested in it, I can send you to it. This was her sampling scheme. So she, in this case, the swervy line is the river, or the point of flooding there, and then she looked in, again, I'm going to cheat, 100 feet, which is 30 meters, all the way up to 1,600 feet, which is 488 meters, looking across the field, and then pulling both grab and composite samples out of the field. She did this over a series of time, but remember I mentioned they had 2 flood events, so she started doing this to look for decreases, and then they flooded again, so she got to start all over again in her work. What she found, though, is that there were not very significant decreases in total coliform bacteria, fecal coliform bacteria, or E. coli bacteria across the course of the study. And if we look at it on a heat map, again looking across, more red being more hot for fecal coliforms in this case, and then going down, we have the different dates of sampling, and so you can look there, 2 lines up from the bottom, that's 4/11, so that's a week after the second flood event. So what you can see is that the numbers were slowly falling, and then all of a sudden they had a second flood event, and those numbers spiked back up again. But pretty significant changes over time. Again, similar to what Laura saw, higher where the water's entering the field. You'll notice at that 1,600 foot mark in that top corner, there's higher counts too. That's actually where all the water was draining out of the field, which is why she went up that high. Okay, not all floodwaters are the same. This is her S-tech detection results, and so you can see that depending on the type of water, she did or did not find S-tech there, and they found more S-tech in samples collected where there was proximity to animal production, which is, again, perhaps not surprising to anybody. Soil moisture did correlate with E. coli MPNs being increased, and that, interestingly, after the first flood, for salmonella, 5% were positive. After the second flood, 3% were positive. This is very different than the S-tech data, where they didn't find any or very few S-tech positives after the first flood, but then had up to 42% S-tech positives after the second flood. So some really interesting changes in data depending on flooding, and depending on the type of flood water coming in and the number of floods that you see in a given year. So again, the industry guidance that sort of comes from all of this is that fecal coliforms, which is sort of where we've set our standard of measuring return to normal, are probably not our best indicator. Not all floodwater has equal risk. It really depends on where it comes from, and that bacterial numbers decline over time in all locations. So with that, Channa, Laura, and myself all have a part of a larger project called Contact. We have a YouTube channel where we hold a number of different videos, including videos like this that are available for folks to watch. So I would encourage you to go there, and I'm glad to answer any questions if I left myself a minute for that.
Thank you very much, Michelle. Any questions for Michelle? Roger.
Hey, thanks. Hopefully not a stupid question. First one, you said you flood it deliberately.
Yeah.
Is that to stop erosion? Like, as in, rather than just...
Yeah, so there's a lot of reasons we flood deliberately. We're going to flood anyway, is reason number one. Reason number two is to prevent soil erosion, to drop the erosion away. Reason number 3 is that when we flood those fields, we drop nematode and plant pathogen numbers over the course of the year as well. So there's a number of benefits to flooding those fields, yeah.
And secondly, sorry, you mentioned like with the dry soil, there's normally a lower bacterial count. When you have high sunlight days and also even a bit left field, but have you considered like, is it surface? Can you UVC, actually sanitize the soil? Oh, that sounds a bit
Can you
left field,
UVC surface sanitize it? You probably could, but over the areas, I'm not sure it would be practical. We do have data that looks at sunlight versus microbial decline. The problem is we have yet to, the problem is you can't run a controlled experiment to look at that. You could run a controlled experiment to look at that. We just haven't. So we do see correlations between that. I will tell you, when we look at decline rates in soil over time in Florida, I'll speak for Florida because that's where I am. It might be different in other places. We actually see the highest correlation with changes in relative humidity over the course of the day. And so the lower the change in relative humidity over the course of the day, the smaller the decrease that we see.
Thank you.
Yeah, hi Michelle. Look, my question was a little bit along the same lines as that one. Was when Laura and Chana did their studies, they were doing drag swabs, and just looking at the photograph, it looked like the surface was really dried out, as it would be in the US. I think New Zealand conditions are slightly more temperate. I'm not sure that there would still be moisture below the level, below the surface, and I'm just wondering if salmonella would survive for longer.
Yeah, and so that's why
the surface.
We did the composite samples as well, where we go down
Yeah.
6 inches, which is 15
okay.
centimeters. So we do both of the sampling in general. I think it's more dependent on the type of soil
Yeah.
than the temperateness. So where I am in Florida, we drain at 18 inches an hour, right? We can get 18 inches of rain, and that's how quickly as long as there's somewhere in the groundwater table for it to go, it'll drain at 18 inches an hour. The more clay soils that you see in the Salinas Valley drain at 1 to 2 inches an hour. So I think it has a lot more to do with the soil type.
Yeah, and I think that raises a really good issue that it's worth looking at the sort of soil types and what have you here. I remember something from years ago when they said that the best soils in New Zealand for dairy farming will be where we have our forests up around the plateau, and the best places for growing trees would be down in the Waikato where it's all flat. And that was quite interesting. It just shows you that the selection of soil type for what you're trying to do is very important from a microbiological aspect.
That's the opposite of what we do.
Thank you.
Thank you, Michelle.